Welcome back to the last lecture. This will be chapter 15, Introduction to Statistics in R. So some definitions of statistical concepts. We want to go ahead and quickly define what a statistic is. It describes a sample of your data. A parameter describes a population. So for example, from the MT cars data set, you find that 49% of cars have a 6-cylinder engines. That's your parameter. It's taking all of your data and it's making a conclusion. And then from empty cars, you pull a random sample from it and find that 54% of cars have a 6-cylinder engine. Moving on with statistical concepts, there are often times you will be working on samples of larger data, which is where you will get statistics on a given population. Typically with either statistics or parameters, you want to go ahead and look for the mean, median, and mode. These are things that I hope you've seen in previous classes. If not, we're going to quickly go ahead and look over them, but I'm not going to dive into too much of the details of what each of these mean, because you've probably covered them numerous times in other classes. So here are some functions used to determine what each of these values are from the data on hand. You can use the mean function to find the average, the median to find the median, and here's the tricky part, getting the mode. The mode is not standard to our language. You're going to have to download other packages or get creative as to how you find the mode for the data set. Now there's libraries like dplyr where you can go ahead and type in dplyr : mode, and you'll be able to go ahead and find the mode given that library. That library specializes in statistical analyses. Here we're just working with base R functions. So one way to do it is to get the mode is to get an object in the table format and get the max value. So we see here the max value in this table is 2. If you want to get the values that correspond to 2, you can go ahead and use one of the many subsetting functions that we've covered in previous chapters. So exploring through your data will require a sense of curiosity to find out where the data points fit. Getting counts, percentages, and proportions are usually a good start when starting with any analysis from data you've acquired or have been given. Once again, we'll be working with the MT cars data set. Here's the data frame on the right of what the values look like, what the shape of it is, and what we can do to learn all these concepts. So once again, we can take a look at the table of MT cars. We're going to take a look at the miles per gallon column. Now, percent rank is an option that you can use, or a function that you can use that can give you the percent rank within all of the miles per gallon within each value in the MT cars miles per gallon column. Prop table is the proportion. So this is all based off of proportion. You will be getting a proportion of 0 to 1, which is why these values start with 0.0. They should all add up to 1 at this point. So once you have an idea of what your data contains, the shape of your data, and some basic statistics, you can dive into more descriptive statistics, like calculating variance, standard deviation, and interquartile ranges can further help you understand your data. The standard deviation of an observation variable is the square root of its variance. Your variance is a numerical measure of how the data values are dispersed around the mean. So your distribution falls well within these parameters, and we'll be diving into that in a moment. The interquartile range of an observation variable is the difference of its upper and lower quartiles. So typically you'll see your 25th quartile, your 50th, 75th, and those are broken down into box plots that you've probably seen in the past, or you can see within ggplot2. But your interquartile ranges measure how far apart the data is spread from itself. Now, acquiring the standard deviation, the variance, and the interquartile range in R is quite simple. The functions are very easy to remember. SD will be your standard deviation, var is your variance, and IQR will be your interquartile range function. These can be used to calculate your descriptive statistics, which we see here on the right. Now, some more concepts to go over. Your covariance of two variables, x and y, in a data set measures how the two are linearly related. A positive value indicates a positive linear relationship. A negative value indicates a negative linear relationship. The correlation of the two variables in a data set equals to their covariance divided by the product of their individual standard deviations. Sorry. So values for covariance and correlation can either be positive or negative. The function call for covariance and correlation will require two variables passed in order for them to be calculated. Remember, you're trying to calculate the variance between two variables and the correlation between two variables. So you're going to have to pass two variables in order to get this calculation. Here on the right, we see the calculations being done with their correct functions and their results. Keep in mind, sometimes, or the grand majority of the time, you're going to want to assign these values to a variable so you can hold that value somewhere in memory and refer to them later on down the road. But this should get you started in order to get the work done for this week. And I hope you guys have a good time with getting your work together for the final. Best of luck.